जी, अस्सलाम वालेकुम अहमद।
अस्सलाम वालेकुम सर, कैसे हैं आप?
बिल्कुल खैरियत से। आई होप ऑल्सो वेल एट योर एंड एंड गुड। और आज आपको पता ही है एजेंडा के हवाले से यू हैव टू सॉर्ट ऑफ फिनिश अप विद कल जो आपने बात स्टार्ट की थी। आज आप देख लीजिएगा। ये ज़रा थोड़ा-सा मैं पिछले 2-1 दिन से ऑब्ज़र्व कर रहा हूँ क्योंकि हमारे पास मिक्सचर सा है और थोड़ा-सा अटेंडेंस भी कम है, 2-1 लोग मिसिंग हैं।
जी सर।
तो दे डोंट हैव हालाँकि सबने मास्टर्स किया हुआ है, रिसर्च में रहे हैं, तो वो ज़रा
जी सर।
थोड़ा-सा जब आप ऐसे फ़ोकस के साथ करें तो चीज़ें ज़रा थोड़ी-सी तो बहुत ज़्यादा इन डेप्थ शायद अभी इनका वो नहीं है
जी सर।
लेवल। तो आई
जी
एम
सर।
जस्ट लेटिंग यू नो कि अभी तक जो मैंने गेज किया है ना इनके साथ पिछले 1.5-2 दिन
जी
से
सर।
जो एंगेजमेंट रही है, स्टडी डिज़ाइन्स, फिर कल रोलो के साथ भी था। तो सो आई एम जस्ट गिविंग यू दिस हेड्स अप।
जी सर।
बाकी
जी
तो
सर।
बाकी तो आप वो बहुत अच्छे तरीके से डेमोंस्ट्रेट भी कर देते हैं। हेल्प देम, इसमें रिकॉर्डिंग भी आ जाएगी। हेल्प देम अंडरस्टैंड कि पी वैल्यू क्या है, ओ सॉरी क्या है,
बिल्कुल।
कॉन्फिडेंस इंटरवल का रेंज है, 0 में से अगर गुजर रहा है, डिफरेंसेस अगर आप
बिल्कुल
देख रहे हैं, मीन्स के डिफरेंस का कॉन्फिडेंस
सर, ये
कॉन्फिडेंस
ये
इंटरवल।
चीजें जो थी ना, हमने सर सारी कवर की थी मेटा एनालिसिस में। तो वो तो 3-4 डेज की वर्कशॉप थी। तो उसमें
हाँ
ये सब
ठीक है।
चीजें हमने कवर की हुई थी। इफेक्ट साइज,
बस
कॉन्फिडेंस
फिर
इंटरवल्स हो
अहमद
गए।
हल्का सा ना टच बेस कर देना और
जी सर।
रिमाइंड करा देना कि हमने ये था किया हुआ कवर पहले।
बिल्कुल बिल्कुल। जी
ठीक
सर।
है। तो चलो Nida will join in a little bit of a delay. She's attending to some work.
जी सर।
So once you start the I'll do the recap. थोड़ा सा आप भी recap कर दीजिएगा कल का,
जी सर।
and then I'll hand it over to you. I'll step away. I have to attend to a couple of things grant related. So
जी सर।
I have to dispatch them off. I'm working with Mohsin. So
जी बिल्कुल। जी सर।
I'll be on mute. Uh, so if there are any, so just type in. ठीक है?
जी बिल्कुल बिल्कुल। जी सर। जी सर।
Right. Okay. So we have our people joining in. I see Nadi, Pragya, Krishani. Good afternoon. Good evening. So we're just waiting for Prasansa, and I hope Nabi, Shamoon's feeling better, and please do ask him from all of us.
Okay, yeah. Yeah, I did had a talk with Dr. Shuman in the morning.
Yeah,
I'm not sure whether he will be able to join today
that's fine.
because he needs to take his son to a doctor.
No,
So it's
no
like
worries,
going
no
through a bad
worries.
time.
No worries, no worries. The good thing is all of these sessions of ours are being recorded. We have all the materials on PebblePad, so no worries. Uh, as long as all is well at his level and his family's level, so please do ask him from our side. And
Sure.
Krishani, I hope the same is she's fine. Asiri is fine. So please give her our regards.
Sure, Dr. Siham. I just text her.
Yeah.
I think maybe she won't be able to join today as well. Yeah.
No worries, no worries. Just ask her from our side.
Okay,
So
thank you.
no, thank you. Good afternoon, Prasansa. Glad we are all here now. I think we can kick off. Nida will, she's attending to, we're putting in a couple of grants next week and then another one following that. So she's just caught up with that too. So she'll join in a bit, right? So just a very quick recap, and please, dear fellows, pitch in if I miss anything. And I will also request Dr. Ahmed Waqas to also add to the recap or have the recap asked from all of you. So yesterday we covered the remaining part of the overview, and perhaps to help you gain some insights, or rather some, add something to your vocabulary in terms of if you take an intervention which has been proven effective, has been evaluated through randomized trials. Now, if you want to scale that up, why do cluster randomized controlled trials fall short of being used in evaluation when you start scaling it up, when you start increasing the scale of the context, the organizations, etc., and how do you ensure that there is good enough, robust implementation, the procedures, the processes are in place to still keep your clinical outcomes effective. That's where randomized controlled trials fall short. They still are, they will still be, as per today, they are still the gold standard for evaluating clinical outcomes. So I then introduced you to the concept of how do you implement and disseminate the terminologies that are used within implementation science. How do you use if implement effectiveness implementation hybrid designs? There's still trials depending on the level of evidence. You keep your either clinical outcomes as primary and implementation outcomes as secondary. So that's type 1. We looked at type 2 hybrid designs for effectiveness, implementation effectiveness, hybrid designs. Type 2 is looking with equal focus on your clinical outcomes as well as your implementation outcomes. And then there's the third type of randomized trials, hybrid trials, which have the sole or primary outcome is all about implementation, processes, and your clinical outcomes then become secondary because you've gone through that cycle of establishing that your clinical outcomes have been shown to be effective. So we also very briefly talked about the types of frameworks that we have. There are numerous. I intentionally didn't want to confuse you with. There are many ways of assessing implementation. There are numerous frameworks. People have been at it since the last 2.5 decades. I then also introduced you to the concept of when more than one intervention is at play. So for example, for maternal depression, we established that Thinking Healthy program is robust, it's effective. Now, what will happen if a program, an MNCH program needs to use this, or in Nepal, community-based female voluntary people have to use this? How will they detect who will the Thinking Healthy program be given to? So the minute that you start thinking about detection, that's another form of an intervention. How do you then detect? How then do you link them up with the designated health systems? How do you then refer to other sectors? How do you ensure social determinants are also addressed? Now, we started to talk about more than Thinking Healthy program. Other interventions become attached with this once we start looking at maternal depression. So now this has become a program of intervention. And here RCTs, hybrid designs fall short. And more recently, from the work of HIV/AIDS, there are a couple of global health champions who've been pushing program science as a discipline of assessing programs. This program science led by James Blanchard, he's a professor in Winnipeg University, along with Arel and colleagues. So they're pushing the global health arena to think of interventions as programs, and you embed some science in it. So program science is an evolving discipline to assess a set of interventions in a form of program. Then very kindly, Professor Dwala Wong gave us an overview about power size calculations and the kinds of assumptions and the pitfalls that are linked with this. The bottom line was larger the sample, better the precision, better the power. We also specifically queried him that if there are any resources, because we're all struggling or we're all planning to do some form of feasibility or pilot studies within our site. So what's the optimal sample size for that? So he was very clear about it, that there is no sample size as small as 25 per arm to maximum of 50 per arm is fine. And he referred to a reference which we all can use. And we will put up all the resources that he's shared on PebblePad. Then Dr. Ahmed Bakar stepped in, provided you some overview of what analysis should look like. So Ahmed, if you want to recap, ask the fellows what was covered. So over to you. And then you can slip into your session and complete the conducting of analysis in quantitative studies, looking into more inferential stats, continuing your discussion and presentation from yesterday. So over to you.
Thank you so much, Dr. Sihan. So let me please summarize what we had covered yesterday. So we had talked about essentially talked about how do we summarize quantitative variables and categorical variables, and how do we describe a single variable. We went through the concepts of mean, median, and mode as important concepts in presenting central tendency of a particular variable. We also talked about dispersion, the concept of dispersion, and we explored the concept of variance, standard deviation, confidence intervals, standard errors, interquartile range, and range. And then we explored different visualization techniques, including histogram and bar charts and pie charts. Simple visualization or graphs or figures, whatever you may call them, to present the distribution of a particular variable. So these were the steps, the basic steps every data analyst should know, because you need them to describe your data when you're talking about a data set or principal investigator. Maybe you would like to give these values to a statistician for calculation of sample size, or maybe you may need to know the distribution of your particular variable to conduct complex inferential statistics. Now, I know that most of us come from a variety of backgrounds, and it would not really be easy to grasp all these statistical concepts within a few hours. So I do acknowledge that, and perhaps teaching statistics in simple words without the use of equations is never easy. But I try to demonstrate it on SPSS, giving practical examples for all of these concepts. And I hope that that all of you have were able to understand some of the content or most of the content. I also shared a reading material previously, which gives you demonstrations of the use of SPSS. But yesterday, I also recommended Oxford Handbook of Medical Statistics uh, because that handbook explains a lot of these concepts in much more detail. Uh, uh, thinking, taking the readers from different backgrounds or different disciplines. So you don't really have to be a statistician to understand that Oxford Handbook. So that is a really good resource. But I do understand that some of us come from non-technical backgrounds as well. So all of you are welcomed to have one-to-one sessions with me, individual sessions with me as well. So I should be able to finish my dissertation by the end of December. And after that, you can just CC Dr. Siham in the email and request a session with me as well, where I can take you through statistical techniques or help you with your own data set as well. And I would also like you to link this statistical workshop with the workshop that we had conducted for meta-analysis. So a lot of these concepts, such as concept of effect sizes, mean differences, confidence intervals, coherency, standardized mean differences. So we had covered a lot of different statistical concepts in those workshops as well. So you have to link this workshop with the previous one on meta-analysis as well, just to have a broader understanding of all of these statistical concepts. And other than this, let me try to take you through different types of statistical tests. We will cover about 5 of them today, using which you can analyze your data sets as well. But these 5 or 6 statistical tests are not the whole spectrum of the statistical techniques you should know as a data analyst or while working in your PhD data. You would need to know a lot more statistical techniques if you are to get or infer better insights from your data, but they should be good as a start. So try to master these techniques, try to practice them using the videos that would be shared with you, or the video of this workshop. And I will also try to share some good websites with you all, that which can and even YouTube tutorials which can take you through different statistical techniques as well. So even more advanced techniques, the ones which we do not cover in these workshops, you can ask me to give you a demonstration on those techniques later on, or maybe you can request for a YouTube tutorial, or maybe any reference to a research paper or book. Just mention the statistical technique and we'll find out the material for you and share it with you, just to make your learning easy too. And this way I can learn better as well. So up till now, does anyone have any question? I'm not still familiar with the kind of study design that you're going to use for your dissertation. And so I think once I know what study design you're going to use, we can have a better one-to-one sessions as well. So do you have any questions so far? Any questions?
And if I may add, Ahmed, I think that's a That's a good starting point, knowing what the potential study designs might be for their individual PhD topics or the kinds of work that sites are doing or are planning to do. My sense till now, Ahmed, is that there is something which all of the PhDs, the fellows will be doing in terms of their PhD. The scope will be of their dissertation will be A. B, on the side, they'll be planning to do a number of other things which will not be part of their dissertation. So for example, I'll just, for it to be concrete, for example, in Bangladesh, perhaps more qualitative approach and focus will be undertaken as a design to try and inform if using mobile or mHealth or E-type of materials within slums might be feasible for maternal depression. And this process, the qualitative process, will be informed by a standalone on the side outside the scope of PhD, a survey, a quantitative survey that Nabi and team and Professor Umar are planning to take, and that will kind of triangulate and feed into the findings of the qualitative. So, so in any case, I think having some idea of their research design based on their research question, it will be good for them to start, even if it is not part of their PhD as such. If they have the bandwidth, I think that will be worthwhile because it's all in the same direction. We are all here to try and support them and learn as well. So I'll stop here. I'll let others pitch in if that's the case. So over to you, Emma.
That sounds great. And once I get to know what kind of projects all the teams are planning, maybe we can, in addition to having one-to-one sessions, maybe we can have a workshop related to similar techniques, maybe, right? So maybe 2 or 3 of the fellows may be using the same kind of study design, or maybe answering a similar kind of research question. So we can have group workshops as well. And that would be good for the learning of the fellows and as well as my own learning as well, because I get to explore a topic in more in greater detail that way. So I'm open to it, and anyone can approach me for a one-to-one workshop or maybe a group workshop. And just CC Dr. Sihan Savian, so he's in loop.
Thanks, Ahmed, the star. So please carry on. I'll step away for about 10 minutes. And then I'm still on mute. So just keep typing in questions if there are any.
Sounds good.
Pointed towards me. Thanks.
So Ahmed, just checking in. So you said you will be open for one-to-one sessions if needed after December, right?
Yes, that's correct. Yes.
Because
in December I finished the last research paper of my dissertation. So after that, the process would be really easy for me. My schedule would not be too hectic.
Sure, thanks.
So, should I begin with the presentation, with the workshop?
Yes, please.
So we'll be talking about a few basic statistical techniques. So I found a really good flow chart on deciding what kind of statistical test we should be using based on our research question, or based on the type of variable that we have. So yesterday we had covered 2 types of so the learnings that we had yesterday, now we have to apply them on this particular module. So we talked about 2 kinds of variables: categorical variables and continuous variables. So the categorical ones were either binary like gender, male or female, or maybe they had more than 2 categories, right? Maybe such as socioeconomic status, from poor, medium, from low middle class to middle class to upper class, upper socioeconomic class. So this is one category of the variables that we had talked about. The other one was the continuous one, where we talked about interval, ratio, and we also talked about discrete values. So discrete values would be integers with values such as 0, 1, 2, 3, and the rest were interval and ratio with quantitative values, but with decimal points. So for instance, if we talk about height of an individual or the weight of an individual, the weight may be 70.32 kilograms, right? So all of those are examples of continuous variables. So the choice of the statistical test would depend on the type of variables that we have and the type of hypothesis or research question that we are trying to answer. So if you have categorical data, so if you would like to check association between 2 categorical variables, the test to be used is chi-squared test. So this is a test that we had applied yesterday using the cross tabulation method in SPSS, and I will demonstrate that again today using SPSS. So the chi-squared test as well as the Fisher exact test, both of these are done for variables that are categorical. So your dependent and independent variable, both of them should be categorical. And for continuous variables, you will have 2 kinds of hypotheses or 2 kinds of research questions. The first one is difference type of research question. So maybe you would like to know that is there a difference in mean scores on PHQ-9 among between the boys and the girls, right? So you have a group and a quantitative variable. So this is the difference type of research questions. The other type of research question here, or the other type of statistical techniques that we're interested in relate to the relationship or association. So maybe you would like to know what is the association between depression scores and social support scores, right? So both of them are quantitative, and you get to know the relationship or association between them. And the relationship association between them could be negative or positive, right? Or direct relationship or inverse relationship. So coming on to the difference type of question, how do you select the type of test that you are going to use? If your outcome variable or dependent variable is continuous, such as PHQ-9 scores, but the independent variable is binary. So you have only 2 categories, right? And if you look at the PHQ-9 scores and the data is normal, and the distribution of PHQ-9 score is normal. So we talked about the concept of normality yesterday. The data is normal. PHQ-9 has a normal distribution, which you can evaluate using a histogram. Then you use t-test, independent sample t-test. So t-test would essentially answer, is there a difference in PHQ-9 scores between the boys and the girls, right? And if the data is non-normal, is not normal, has a high variance, high standard deviation, and the histogram is highly kurtotic and skewed, then you use Wilcoxon Mann-Whitney U-test. And if your independent variable, if your outcome variable stays PHQ-9, scores on PHQ-9, i.e. they are continuous, it is a continuous variable, but your independent variable has 3 or more categories, right? So for instance, socioeconomic class, low, middle, high, low, moderate, high, or you may have you may have people from three different districts or three different countries, like Pakistan, Sri Lanka, and India, right? And you are trying to see if Pakistan, India, and Sri Lanka have different scores differ in PHQ-9 scores, then you would use one-way ANOVA. So you have your independent variable has 3 categories or more categories, and your outcome variable is continuous PHQ-9 scores. You use one-way ANOVA. And if the distribution of PHQ-9 is non-normal, then you use Kruskal-Wallis test. So these are called non-parametric techniques, which can cater to the dependent variable that does not really have a normal distribution, as shown through a histogram or maybe standard deviation, variance, kurtosis, and skewness values. So we will talk in more detail about these when we run these tests on SPSS, right? Coming on to the relationships. So you have a dependent variable that is continuous, or maybe 2 values, for instance, social support and PHQ-9 scores. You can use correlation, Pearson correlation, or Spearman test, right? So if the data is normal, you use Pearson test, Pearson correlation, and if data is non-normal, you can use Pearson ranked or Spearman-Drew or Spearman test or Kendall-Stowe test, right? So this says, have you a true dependent variable? No. So this just means you're trying to look at correlation between 2 variables. You do not really have a true independent or dependent variable. But if you have a true outcome, true dependent variable, you use regression technique, regression analysis, right? So this regression analysis, again, the technique that you're going to employ in regression analysis, we use two main techniques, or 2 most commonly techniques called linear regression and logistic regression. So if your outcome is continuous, you use linear regression, for instance, PHQ-9 scores. But if your outcome is, let's say, binary, depression status. So depression, a person could be depressed or not depressed. Then you use logistic regression, a binary logistic regression. And if your outcome variable, let's say depression status has more than 2 categories. So let's say the depression status has been defined as no depression, mild depression, moderate depression, severe depression, then your outcome variable has more than 2 categories. And in that instance, you will use multinomial logistic regression. But for the sake of this workshop, we would not be covering logistic regression. We would only be covering linear regression, because we don't really have a lot of time on hand, but we can always organize one-to-one or group workshops later on. So I've been talking about parametric data, parametric test, and non-parametric test here, right? So you have clear dichotomy here. So what does that mean? So if your data fulfills these 4 assumptions, then they fulfill the assumptions of parametric testing statistical techniques. Otherwise, they should be analyzed using non-parametric techniques. And we will explore these assumptions in much more detail later on when we run individual tests. The first one is normality. Data should have a normal distribution, or should at least be symmetric. There should be homogeneity of variances. So when we are doing independent sample t-test or one-way ANOVA, so we have multiple groups in those, right? So all of those groups should have the same variance. Linearity, when we talk about Pearson correlation or linear regression, where we are trying to check association between 2 variables, the association should be linear. So for instance, you have a graph, the association should be linear. So depression scores or anxiety scores, maybe social support and anxiety scores, but it should be linear, right? It should not be quadratic like this, or it should not be cubic, right? So it should have a linear association. And independence, data should be independent. So what does it mean? That it should not be, for instance, let's say time series data, or it should not be a longitudinal repeated measures type of data where where all of the data points in series are correlated. So they are not truly independent. So this is the fourth assumption of these parametric tests. So I will take you to SPSS and try running all of these statistical tests, right? And then we'll come back to these slides and try to explore the output in more detail and try to make sense of it. Take you to. Can everyone see the SPSS software?
Yes.
Okay. So let me take you to the Analyze ribbon tab, Analyze drop-down menu here. We go to compare. So the first technique that we're going to run is the independent sample t-test, where we're trying to answer research questions such as, is there a difference on PHQ-9 score between the boys and the girls? So the independent variable is gender, boys or girls, dichotomous with two categories, and the outcome variable is PHQ-9 scores, which is a continuous variable. So we go to compare means. So this just means that this drop-down menu has a number of statistical techniques that are useful for checking mean differences between different groups of participants. So we go to independent sample t-test. Grouping variable, our grouping variable is gender. Group 1 is boys and group 2 is girls, which I have coded as 1 or 2. And our test variable or outcome variable is PHQ-9 scores. It's not really change any of the options here. So you see there is only one thing of interest here, confidence interval. So 95% is the value that we're interested in. So we had talked about our confidence intervals in the meta-analysis workshop and as well as yesterday. Click OK. So this is the output that we get from it, right? So let me go back to the PowerPoint file and we can try to make sense of it. So this is the same output that I had copy pasted here on the PowerPoint. So look at the first table there, group statistics, right? Total scores on PHQ, boys and girls, the independent variable and the dependent variable. N is the sample size here. So there were 88 boys and 364 girls. Look at the mean scores. 6.82. The mean PHQ-9 scores for boys were 6.8295. And the mean scores for the girls were 7.675. So we can already see that there is a bit of a difference on PHQ-9 scores among the boys and the girls, right? Look at the standard deviation. Look at the standard deviation. You see that the standard deviation for the boys is 4.48 and for the girls is 5.79. So even standard deviation is a bit different, right? So previously, while looking at the choice of statistical tests, we had talked about homogeneity of variance between the groups, that the variance between the groups should be almost equal. But you see here that the standard deviation is a bit different, right? And what is standard deviation? It is under root of variance. So we already see that the variance is a bit different, or standard deviation is a bit different. So we don't really fulfill the assumption of homogeneity of variance for independent sample t-test, right? So please keep this in mind, that the variance between the groups is different, and the mean scores seem to be different between the boys and girls as well, right? Now let's go on to the next table. So it gives you the Levene's test for equality of variances. So it is a statistical test that that tests the hypothesis that the variance between the two groups is equal, right? So that's a null hypothesis. And you can see here that the significance value of p-value is less than 0.05, right? So we'll reject the hypothesis that the variance between the groups is not equal. That was our alternate hypothesis. It's not equal. So we do not really fulfill the assumption for independent sample t-test. We are violating the assumptions, right? But with the advent of statistical software, techniques such as t-test, independent sample t-test, as well as one-way ANOVA to test group differences have become really robust, right? So the SPSS gives you an option that if the variance between the two groups is equal, you can read this output, this line. If the variance is not equal, then the SPSS software, any statistical software for that matter, will adjust your statistics for the inequality of variance and give you related data, this data, right? Now, let's go on to interpret the independent sample t-test. So now we know that the variance is not equal between the two groups. So we go on to the second row of numbers here. You have two or three values of interest here, right? So earlier on, you saw that that boys have a lower mean score on PHQ-9 as compared to girls, right? So we say that boys have a lower score on PHQ-9 as compared to girls. But is this difference in means, is this trend or is this group difference statistically significant, right? So that is the main question that we have to answer. So you look at the significance two-tailed, the two-tailed p-value here. The p-value is 0.137. So it is greater than 0.05, the cutoff that we take while we set our significance level. So it means that there seems to be a small difference between the boys on the PHQ-9 scores between the boys and girls, but that difference is not statistically significant. Now, how did we come to this p-value? So what? So that this p-value came through. So when we run t-test, what we do is t is equal to mean difference over standard error of difference. So when you take this value here and the standard error here and you divide them, you get the t value, right? And then the t value is compared against the corresponding p value, and that is how you get your p value, and you get to know if these differences are significant or not. Now there is another table here, independent sample effect sizes, but you do not really have to worry about this. But I think the only one of the only statistic of interest here would be point estimate, negative 0.15, right? So this is the Cohen's d. So we had talked about Cohen's d and standardized mean differences in the meta-analysis, and this is equal to those effect sizes. So you see that the value negative 0. That the point estimate or the effect size here is negative 0.15, which is a very weak effect size for this particular association, right? So there seems to be a difference between the mean, but the effect size that they yield is very weak, so not a lot of difference, and the corresponding p-value is greater than 0.05. So does anyone have any questions so far? Would you like me to summarize it again?
Eamon, I'm just wondering, so in the independent samples test, you said the differences are not significant. So
Yes.
I mean, it's not equal. You said equal variances assumed. You said the difference is not equal. So how do you come to that conclusion? What is the number if we have to say that it is equal or not?
So the variance, this was just an assumption, right? You have to know if the variances are equal as a qualifying condition for t-test, right? So first, you have to establish that variances are equal. So how do you look at the variances? So yesterday we had talked about variance and standard deviation and dispersion, right? So you see here that the variance of PHQ-9 scores for boys is 4.4 and for girls is 5.7, right? So what is standard deviation? It is just the under root of variance, right? So you can see here that the standard deviations and the variances are quite different for boys and girls. So we did not really fulfill the assumption for the t-test. So that is how, and this Levene's test for equality of variances looks at these values of variance or standard deviation and gives the p-value, corresponding p-value 0.09, and shows you that that the differences in the variance between the two groups on PHQ-9 scores is indeed significant. But this does not relate to the t-test itself, but it is actually a precursor or qualifying condition for the t-test. And then we said that that previously, when we used to do statistics with hand manually, we had to be worried about the variances between the groups, right? So if the variances during that time were different, we would choose some non-parametric test. But with the passage of time and and with the development of statistical software, these techniques have become more robust. You do not really have to worry about equality of variances now, because these software give you adjusted values. So even if the variances are unequal, you can still use t-test or one-way ANOVA here, or tests that give you statistical significance for group differences. So does that make sense? We talked about this.
So either way, t-test does make sense, right?
Yeah, because
Okay.
Because even though the difference in variance between the two groups is significant, we can still use these adjusted values, because the second line, equal variance, is not assumed. It actually adjusts your statistical test, your statistical value for when the condition for equality of variance is not met. So does it make sense?
Yes, it does.
So let's move on to the next one. Let's move on to the SPSS now. The next test of interest would be one-way analysis of variance. Let's go to compare means. Again, because we are looking at group differences. One-way ANOVA. So one-way ANOVA is like independent sample t-test, but But the independent variable here has more than 2 categories. So what I have done here is I have chosen within the past 6 months, have you at any point felt a need for outside help, right? And it has 3 Likert type responses. No help, I have felt the need for help, yes, I have sought outside help. So these are the responses in this statement. So 3 categories. And then total score on PHQ-9 that goes into the dependent list, right? And we press OK. Let me do it again so I can demonstrate it better way. Okay. So this is the statistic that we get. Let me take you so let me just try to explain it here a bit. So this is these are statistics that you get through one-way ANOVA, and you look at the significance value here. It shows you that the p-value is equal to 0.014, so less than 0.05. So it means that there are group differences in among people who did not seek help, who felt the need to seek help, and who did seek help. These 3 groups indeed differ on PHQ-9 scores, right? So this is information that we get from one-way ANOVA. But what we want to do is we would like to know if all of these groups differ from one another, or do only specific groups differ from each other. So what we do is we go back to one-way ANOVA, and you click on post hoc. So you have the factor and the dependent variable in. You click on post hoc. You click on Bonferroni test. Equal variance is assumed. So this is the equal variance again with just like what we had seen in the t-test. We click on Bonferroni test here. Continue. We go to options. We click on means plot. And in statistics, we click on descriptives and homogeneity of variance test. So the same homogeneity of variance test that we saw in t-test. We click continue. Okay. So previously, we had only one table for one-way analysis of variance, where we saw that these groups indeed differ on PHQ-9 scores because we have a p-value statistically significant p-value. Now we go on to the first table. The first table is titled descriptives, right? So it gives you sample size for each group. No, I have not felt the need, 138. I have considered getting outside help, 84 sample size, and I have sought outside help. So 230 of the participants endorsed that they have sought outside help. And these are the total number of participants. Now you look at the mean values, mean PHQ-9 scores for each of the group. So the first group has a mean value of 6.41. So the second one has 8.42. So this group seems to have higher PHQ-9 scores than the previous one, right? And I have sought outside help, 7.83 scores. So about in the middle. Now you look at the standard deviation, 5.35, 5.66, 5.57. So you see that these standard deviations and as a proxy measure variance, they do not really differ against one another, right? There's not much difference in variance between the 3 groups. And it seems like the variances for these 3 groups, these 3 subgroups, are indeed homogeneous. So these 3 groups have similar variances. And this is indeed confirmed on this test of homogeneity of variances, where you see that the p-values are indeed greater than 0.05, confirming your alternate hypothesis that confirming your null hypothesis that the variances between these three groups are indeed homogeneous. And then you get the one-way ANOVA table that we had talked about previously, and we will explore this in more detail once we move on to the PowerPoint slide. And this table shows you multiple comparisons. So it compares each subgroup with the other subgroups just to see if these subgroup differences are limited to specific groups, or are they universal? Are they present in all of these groups? And then you have the means plot. So you see here that the second category, I have considered getting outside help as a higher mean score on PHQ-9. I have sought outside help is on second number, so just a bit lower than the previous category. And those who said, no, I have not felt the need for getting outside help, they have the lowest scores. So it's really easy to visualize these differences using a means plot. Now let's move on to our PowerPoint slide to further explore these tables. So we have talked about this table, right? That indeed there are subgroup differences between the three groups. Now let's move on to the multiple comparisons. And for getting these multiple comparisons, we chose post hoc tests. So we chose post hoc tests, and the option was Bonferroni. We chose Bonferroni post hoc test here because this particular statistic, it adjusts your statistics for doing multiple comparisons. So if you had just run independent sample t-test to look at if the category of no, I have not felt the need, no, I have not felt the need, compared with I have considered getting outside help, these two categories differ or not using a t-test, that would not have been very statistically meaningful, and that would lead to biased p-values. But Bonferroni, what Bonferroni does is it adjusts for biases that you see in multiple comparisons, just so you could avoid getting spurious significant p-values. So Bonferroni is just a correction method. So no, I have not felt the need, one category, and the rest of the two categories are I've considered getting outside help, I have sought outside help. Now, does this category differ from this one? And does this differ from this one? So we are trying to run pairwise comparisons here, right? So this category has a mean difference. These two categories have this is a mean difference. This is the difference in mean scores on PHQ-9 between these two categories. And you see that we do see that there is a difference between them. The mean difference is not 0, it's actually negative 2.01, right? So we had looked at the mean values in previous tables, and the mean difference we get is negative 2.01. So there is differences, and the corresponding p-value is 0.026. So it's p-value less than 0.05, so it's a significant, statistically significant mean difference. Just like we saw in means plot, that this category has a higher mean score than this one, and this difference in mean score is indeed significant. And when you compare no, I have not felt the need, the mean scores for no, I have not felt the need group with I have sought outside help, the difference in mean would be negative 1.42. And the significance is 0.052. So it's a bit higher than a p less than 0.05, right? So there does seem to be a difference in mean scores on PHQ-9 between these two groups, but it is not really significant. So these are the pairwise comparisons here, and these pairwise comparisons have been run for the rest of the categories here. But these can be these can be really I would say when you're publishing an article in a journal, it's just another table that you do not really want in the main manuscript, and this goes to the supplementary file. I think the more meaningful way of presenting this is using a means plot. So this is a means plot that we got in the SPSS. So you see here the second category has a higher mean score than the third category and the first category. So the highest PHQ-9 scores were reported by respondents who said that I have considered getting outside help, and it is significantly higher than the first one and significantly higher than this, and not significantly higher than this one. Just well, and we came to this conclusion just by looking at the p-values, the pairwise comparisons. So does this make any sense? Or do you have any questions about this statistical test? So if you were to run this one-way ANOVA, would you be able to interpret it? So should we move forward?
Yes.
So the next test would be Pearson correlation. And we said that we use Pearson correlation when we are trying to find association between two variables, two quantitative variables. So we have a range of quantitative variables in our data set. So the first one, the variable of interest would be PHQ total score on PHQ-9. And let's say internalizing problems among the adolescents. So let's see if there are any, if there is any significant association between PHQ-9 scores and internalizing problems as measured using the strengths and difficulties questionnaire. So we go to analyze and we click on correlate, click on bivariate. So this just means bivariate correlation, bi meaning two and variate meaning variable. So association between two variables. You click on total score on PHQ-9 and you click on internalizing problems, scores on internalizing problems, both quantitative values, correlation coefficients, Pearson. So this is the parametric test, Pearson correlation. And the non-parametric test would be Kendall's Tau-V and Spearman correlation. You do not really have to do any, do not really have to click on any of these statistics, any of the options or confidence intervals. Click OK. Yes. So it shows that the total score on PHQ-9 has a correlation of Pearson correlation of 0.377 when we are checking when we check its association with internalizing problems, and this effect is indeed significant. P less than 0.001. This is the sample size here. So this is the only table that's generated on the PHQ-9. Only table generated when we run a Pearson correlation analysis. Now let's move on to the PowerPoint slide and try to see how we can make sense of this data, a sense of this particular statistic. So this correlation is a bit different because I ran it between scores on emotional problems and scores on internalizing problems, right? And you see here that the correlation value is 0.806. And it is indeed significant. And this is the sample size here. So you see that we have got a statistically significant result, a statistically significant association, but how do we interpret it? So you look at the R value here, the Pearson correlation value here, 0.806, and you see that it's positive, right? So the emotional problems and the internalizing problems, they are positively correlated, right? So now you know that there is a positive association between internalizing problems and emotional problems. And how do we, but another important insight, in addition to the direction of this association, another important insight that we get from it is how, what is the strength of this association? So we draw that conclusion from this Pearson correlation value. So so the strength of this correlation is actually based on an arbitrary criteria that we use it as a convention by Cohen, right? So he was a statistician behind this. So he said that if your Pearson correlation ranges from 0 to 0.3, the strength of association is weak. If it ranges from 0.31 to 0.6, you have a moderate or a medium strength of association or a medium effect size. And from 0.6 plus, it is a strong association. So these are the conventions that we use to interpret the Pearson correlation. So looking at this table, we can say that the association between internalizing scores and emotional problems is indeed significant. They are positively correlated, and the strength of association is really strong, right? So this is one of the easier tests to understand. So does this make sense? Now, before running this Pearson correlation, we talked about its non-parametric alternatives as well, right? Spearman's correlation as well as Kendall's correlation, Kendall-Stau, Spearman's rho. So we ran this correlation based on the assumption that our data are normally distributed and the relationship between them is linear, right? We talked about the linearity previously as well. Now, how do we check linearity? Linearity before running the Pearson correlation. Now, let's go on to the SPSS software again, and where we can try to see how to check if the association is indeed linear. Going to the SPSS again, graphs, chart builder, okay. So go to scatter plot, click on scatter plot. This is a simple scatter plot option. Does not seem to reset. Again, going to the scatter plot, click on scatter, simple scatter plot. The internalizing scores on internalizing scale goes to the x-axis, and the emotional problem goes to the y-axis, right? I don't know what the problem is. I cannot really seem to see the options.
Ahmed, is this because of some rendering issue of Zoom? Or
I think it is, but what I'm going to do is I'm just going to press enter.
Okay.
So this will run the analysis.
Okay. I'm just saying if this, I don't know if Let's see.
I'm not really sure. Yeah. So this is the scatter plot that we get for assessing association between scores on the internalizing subscale, internalizing problems and emotional problems. So what conclusions can you draw from this particular scatter plot? One of the things that I see here is as the scores on the internalizing subscale, the x-axis progress, you see that the data points corresponding to the emotional problems also seem to progress linearly. I can well visualize that that there seems to be a direct and positive correlation between the internalizing subscale scores, internalizing subscale, as well as the emotional problem subscale. So as the scores on x-axis increase, the scores on emotional problems seem to increase as well. So it does mean that that the association seems to be linear. I'm going to double click on this, and we are going to fit a regression line or line of or a fit line in this particular scatter plot, which will show us the slope of this particular correlation. So we would be able to visualize if this is linear. So just by looking at the data, I can see that it is linear with increasing scores on the x-axis. Scores on the y-axis also seem to increase. So I'm clicking on add fit line at total. So just by looking at this particular line, we see that it is indeed linear, and it is very steep. So the steeper this fit line, the more positive or more powerful the association between the two variables. So we see that we do fulfill the assumption of linearity here. And this way we were also able to demonstrate our Pearson demonstrate the findings that we had on while running the Pearson correlation. We found that the association between these two variables is indeed significant and is indeed very strong. So this is confirmed on the scatter plot as well. So this is a visualization technique to look at association between two quantitative variables. So do we have any questions so far? Does it make sense? Pearson correlation and the scatter plot. Because now we're going to move to simple linear regression, and all of these concepts of Pearson correlation, association, and this fit line and scatter plot, they would be, we would see them in linear regression as well. So it would be important to have some understanding of this at this stage.
Sure. So does this mean in order to conduct regression, first we have to conduct multiple of these tests?
So for running correlation, we should run these tests of linearity prior to running Pearson correlation. But even after running Pearson correlation, you can use this scatter plot technique or scatter plot graph just to give a visual of what's going on with the association, just to give a visual of the strength of association, just to give a visual of the direction of association. So you see here the direction is in positive. These are directly correlated, and just by looking at the steepness of this fit line, you can say that the association is indeed strong. So it serves both purposes. Number one would be for looking at the assumptions, that if we fulfill the assumption for Pearson correlation, and also to visualize the results of Pearson correlation. So it fulfills dual purpose.
So if I have understood correctly, we conduct the post hoc analysis to see the differences between number of variables, but whereas Pearson correlation, we just need to, we just conducted how strongly they are correlated. So post
Yes.
hoc is for difference.
Yeah, post hoc. So post hoc is run post hoc tests such as the Bonferroni one that we had discussed previously. That comes after one-way ANOVA. So you run one-way ANOVA for checking mean scores, checking if there are differences in mean scores between between three or more groups, right? So that is another category of tests that we had talked about.
So there's two-way ANOVA as well, right? So would that be covered later on?
No, so two-way, so there are a number of extensions of ANOVA, right? So the one-way ANOVA is the simplest one. And then there are two-way ANOVAs, repeated measures ANOVAs, there are three-way ANOVA. And you would also hear about ANCOVA, you would also hear about MANOVA, right? So these are a family of ANOVA tests, analysis of variance tests, but all of them, have different assumptions and they are used for testing different type of hypotheses applicable in different study designs. And we just covered one-way ANOVA. That's just one statistical technique capable of answering a simple research question that do three or more categories of participants differ in mean scores on a particular scale or differ on a quantitative variable. So these are so ANOVA has a range of statistical tests that will not be covered in this particular module because you need a lot of time to cover all of those techniques.
So can you briefly say, like, I guess two-way ANOVA is also used more often. So just a brief description, when should we use two-way ANOVA? Why don't we settle with one-way ANOVA and then go for two-way ANOVA?
So let me take you to the analyze option here again, right? So in compare means you saw that it only gives you one-way ANOVA, right? But when you extend the concept of one-way ANOVA to more complex study designs, those techniques are similar to regression as well, and they are usually called general linear modeling techniques, right? And when you go to this option, general linear model in SPSS, you see a range of options: univariate, multivariate, and repeated measures, right? So when you go to univariate, you see a number of different boxes here. So previously we only had two boxes, dependent variable and fixed factor box, right? So when you're talking about other ANOVA techniques, such as two-way ANOVA, three-way ANOVA, or MANOVA, or even ANCOVA, those are covered in these general linear modeling techniques. So in dependent variable, you may have PHQ-9 scores, and in fixed factors, you will have more than one variable. So in addition to the previous group, we can also add gender here. So let's say, yes, gender of participant, right? You can also add, if you have sought help, where, whose help, right? And you can also have covariates here, right? You can add in covariates, you can add age of the participant. You can even add emotional problems, and your dependent variable is PHQ-9 scores. So in this way, what you're doing is you're trying to see if the dependent variable differs on these fixed factors, gender of participant, if you have sought outside help, as well as different quantitative covariates while adjusting for age of the participant and emotional problems, right? So this one becomes an extension of ANOVA. So if we didn't have these covariates and we talked about two-way ANOVA, then we would have multiple variables instead of just two, like we had covered previously. And if you add quantitative covariates here, it becomes ANCOVA. So it would be analysis of covariance instead of analysis of variance, right? And when you have multiple outcome variables, instead of just one, it becomes multiple analysis of variance, MANOVA. So we will need more time to cover all of these techniques. So it's actually a family of statistical tests. When you go to general linear model, you have multivariate here as well. So this would cover MANOVA techniques. So you can add in multiple outcome variables here: total score, emotional problems. In fixed factors, you can add gender and age. Gender. In covariates, you can add age, and you get similar results to that of ANOVA, but with more insights, with more number of variables. Then in this similar family of statistical techniques, you also see repeated measures. So this repeated measures is for longitudinal studies. For example, a randomized control trial with 3 waves of data collection: baseline, post-intervention, and follow-up, let's say. So that's a longitudinal study design, right? And you have depression scores that is your outcome, and that has been, let's say, measured 3 times. The number of levels are 3 times here. Measure name can just be depression, and it's not there. So this way you see that within subject variables you have 3 PHQ-9 scores, right? So if we had a data set that had a longitudinal study design, the first one here would have received the baseline scores, this one post-intervention scores, and this one follow-up scores, right? And you can click OK, and you can see that, and you would have been able to see if there is indeed a difference in scores on PHQ-9 after intervention and at follow-up, right, while controlling for the baseline depression scores. So this is for the longitudinal study design. So ANOVA is actually a family of techniques, not just one-way ANOVA, but we will need many hours of workshops to cover all of these, to cover the theory behind these statistical analysis, and as well as how to conduct them. Now let's move on to, do we have any more questions, or should we move on to linear regression? So linear regression is also an extension of ANOVA. And you would see how it becomes an extension of ANOVA when we run the analysis. Let's move on to our PowerPoint presentation. So linear regression, what does linear regression do? So previously we talked about Pearson correlation, where you can check for associations between 2 quantitative variables, right? But you do not really have a distinction on outcome variable and dependent variable, or dependent or independent variables, right? So linear regression is a similar technique where you try to check associations between 2 continuous variables, linear relationship between 2 continuous variables. So it assumes linearity as well. And what you are trying to do is you're trying to move a step further from correlation and trying to predict value of a dependent variable based on the value of an independent variable. So for instance, we wish to answer if a person has a score of 27 on PHQ-9, what score would he have on GAD-7, right? If someone has a depression score of 27, what would be the score on the anxiety scale? So this is the sort of question that we try to answer from linear regression. So more specifically, we determine whether the linear regression between 2 variables is statistically significant, meaning is there a significant association? Determine how much of the variation in the dependent variable is explained by the independent variable. Understand the direction and magnitude of the relationship, just like we had defined previously using Pearson correlation. And going a step further, we are trying to predict values of the dependent variable based on different values of the independent variable. And I will demonstrate this when we run linear regression on SPSS. So this is the mathematical notation. So this is the first time I'm bringing in a mathematical notation for any statistical test, because I think it is really important to understand the use of linear regression. So consider the independent variable is symbolized with X, and the dependent variable outcome variable is Y, right? So a linear regression model would be presented as Y is equal to beta naught. Beta naught is the intercept. Beta 1 X, where beta 1 is the slope parameter. We talked about slope when we are looking at the scatter plot, right? And X is the value of the independent variable. And this eta, this epsilon, is actually residual error, right? So what we are doing is we are trying to, with this equation, we are trying to know for any value of X, what would be the value of Y, what would the value of Y be? And in answering any statistical question, there's always a chance of error. So that is why you see an epsilon or symbol for residual here. And how do we define residual in easier terms? So residual is the difference between an observed value of a response variable This residual is often calculated using the least square method. So linear regression is sometimes called least square regression as well. So let's look at this this scatter plot that we often see when visualizing relationships between two variables. So you have, and we will try to fit the equation for linear regression here, right? So on the x-axis, you have the x variable, scores on the x variable, and the y variable, right? And you see that that the data points are scattered across these scatter plot. And there's a fit line between these plots, right? Between these dots, which show that that there's a linear association between these two variables. This is the intercept. So intercept just means what would the value of y be when x is 0? And this is not really something that interests us when we are running linear regression. And then we had talked about slope, the beta 1 that we had talked about previously. So slope is change in y for unit change in x, right? So for instance, if we have value of 8 on x, the value of y would be around 21, right? But there is always a chance of error. So this is the predicted value, right? And there is always a chance of error. So for instance, you see here that if we say for a value of 8.5, almost 8.5, this is the predicted value of y. But at this point, but the data on the equation is here. The data point, the data point that we have in our data set seems to be here, right? So it says that it's around less than 20, 18 or 19 somewhat. So this difference in the predicted value and the actual value that we have is called the residual error, right? And the linear regression by using least square method tries to fit a line on these data points to make sure that that this residual error is minimum at all data points, at all predicted values. So this is the main crux of the linear regression. And while defining the hypothesis for linear regression, so we have two types of hypothesis for any test: null hypothesis and alternative hypothesis, right? So null hypothesis for linear regression would be that H0 beta 1 is equal to 0. That coefficient of the slope equals 0, meaning that there is no association between two variables, or that when one variable changes, there is no change in the other. There is no related change in the other variable. And the alternative hypothesis would be beta 1 is not equal to 0. The coefficient of the slope does not equal to 0. So that just means that this is the null hypothesis, that with change in value of the x variable, there is no change in the value of y variable. And the alternate hypothesis is this, that there does seem to be a significant association, or there does seem to be a change in slope when the value of x increases or decreases, meaning that with every increase or decrease in x, the y value may increase or decrease as well. So now we have to consider both of these concepts together and try to link them up, right? But before running linear regression, there are a few assumptions, just like the other tests that we have been talking about. The data requirement is that the outcome should be continuous, and the independence should either be continuous or binary, or they should be categorical variables that are dummy coded, right? So continuous would be height or age, binary would be gender, and categorical variables could consist of 3 or more categories, but they have to be dummy coded. So what does dummy code mean? So for instance, you have 3 categories, 1, 2, and 3. You have to dummy code them. So dummy code as in represent all of the categories, but introduce them in linear regression model as like dichotomous models. So you take one of the categories as reference, right? Reference should be sometimes coded as 0, right? And you add another category with it, right? So this is 1 and this is 0. So this is one variable where you are comparing category 1 with both category 2 and 3. This is one dummy variable, and the second dummy variable would here would be 1, 2, 3, and you code 1 and 3 as 0 and compare 2 with 1 and 3. So for a variable consisting of 3 categories, you get 2 dummy coded variables, 2 dichotomous dummy coded variables, where the reference variable is 3, right? So these are the data requirements or the variable requirements for linear regression. Then there should be a linear relationship between the dependent and independent variable, and this can be demonstrated using scatter plot, just like previously we had run scatter plot for Pearson correlation. And the linear relation, if there is no linear relationship between these two variables, then you cannot really run linear regression, and you may have to choose weighted WLS regression, or maybe non-linear regression or polynomial regression. So there are a lot of types of regression as well. But the most common way of dealing with the non-linearity is that you just log transform the variable. So instead of choosing the actual values of your variable, you choose logarithmic transformation of those values of that particular variable. We'll try to touch base these transformations as well in some other workshop. There should be independence of observations. So you see, for instance, when you have some sort of longitudinal data or time series data, the second value is always or mostly would mostly be dependent on the previous value. So for instance, the baseline in any intervention, baseline scores on depression would dictate depression scores after intervention. So for instance, if someone, this is called first autocorrelation, right? So time series, you see these in time series type of studies, as well as in randomized controlled trials or any longitudinal cohort. Then there should be no significant outliers or no extreme values. We had previously seen these when we had talked about box plots and assumptions of normality. We had talked about these yesterday, but while running linear regression, you can look at these using the option of case-wise diagnostics, where you label any value as extreme or outlier if they fall out of the values within 3 standard deviations for a particular variable, right? And then there is an assumption of homoscedasticity, right? That the variance along the line of best fit remains similar as you move along the line. So this is done by making a scatter plot of the residuals against the predicted values. I will demonstrate it when I run SPSS. And then the residuals, not the values themselves, but the residuals, the errors of the regression line are approximately normally distributed. This can be done by looking at histogram as well as normal PP plot. And we had seen both these histograms and normal PP plots when we had explored how to summarize data yesterday, right? So let's move on to the SPSS software and try to run linear regression. So I know a lot of this theory confuses us all, but it becomes easier once you have once you run the linear regression itself or any statistical technique for that matter. So we go to analysis, regression, linear. So what we are going to do is we're going to check association between PHQ-9 scores, or we are going to predict PHQ-9 scores using scores on, let's say, we can, let's say, peer problems, right? So our dependent variable here is PHQ-9 scores, and our independent variable is peer problems, right? You go to statistics, click on estimates, click on case-wise diagnostics. We're not going to click on Durbin-Watson test here because we do not really have any longitudinal data or time series data. And we are not really going, we'll click on descriptives, but we'll not click on part and partial correlations and collinearity diagnostics, because these are applicable when we run multiple linear regression, when we have one outcome variable, but multiple independent variables. Continue, plots. Now this particular option helps us to make scatter plot for the actual values and for standardized actual values, predicted values, and the residual values, right? Just to look at if the variance of the residuals is similar on a scatter plot. So we know that that the variance is indeed homogeneous fulfilling the assumption for linear regression. And then we have standard residual plots, histogram and normal probability plot. So what this would give us, it would give a histogram and a normal PP plot for standardized residual plots to look at if the residuals are indeed have a normal distribution, thus fulfilling the assumption of normal distribution of residuals in a linear regression. In the options, if you have missing values, you have three options here: exclude cases list-wise, exclude cases pair-wise, replace with mean. So you can choose either option if you have if you have some missing data in your data set. But if you have a lot of missing data, then we use other regression techniques or other models for imputing missing values. But that is also that would also be needed to covered in some other a separate workshop. Save, you do not really need to save anything from here. These are more applicable for multiple regression when you have multiple independent variables. We click OK now. So we get a number of tables here to interpret. So let's try to interpret these tables. So the first table shows you the descriptive statistics. So mean scores and standard deviation and sample size for PHQ scores and peer problems, right? So 448 of the participants gave data regarding these two scores. Then you see Pearson correlation. So these are this is the similar table that we had seen when we had run Pearson correlation, right? So you have an R of 0.155, so which is a weak correlation, and significance one tail is less than 0.05, so it's a significant correlation according to the Pearson correlation test. You come on to the summary, and you see 4 important statistics here, and these 3 would be of particular interest to us. So this R is just the value of correlation that we had seen previously. This R squared is just the squared value of this R, and then the adjusted R squared is just this value, but adjusted for the standard error in R squared. So what it says is the adjusted R squared is 0.022, right? So multiplied by 100, it shows you that that scores on peer problems accounts for 2.2% of the variance in PHQ-9 scores. So it's a relatively weak correlation, as we had seen previously as well. So peer problems scores only account for 2.2% of variance in PHQ-9 scores. When you look at the next table, now this is a familiar table, the one we had seen in ANOVA, and it gives you the model fit. It tells you if the overall regression model is it significant or not, right? So the p-value here is 0.001. So the regression model is indeed significant, and this has been calculated in a similar manner to the one-way ANOVA table that we had seen previously. Now this table, the table on coefficients, this is the one that would most interest us, and this is the one that we usually report in. We always report in our publication, journal publication. So you don't really have to look at the constant. So the constant is the intercept value that we had talked about. Not very interesting. When you look at the peer problems here, you have several columns. So B coefficient, you have standard error, and then standardized coefficient, standardized beta coefficient. So it is just B coefficient adjusted for the standard error, 0.155, right? The corresponding t value and the corresponding p value less than 0.001. So we can indeed say that for every that the slope, that the beta coefficient or the slope value that we needed is 0.155, and it is significant. So when we look at the scatter plot, fit a line of have a fit line in the scatter plot, we can impute these values in the regression table and try to predict that for a particular value of peer problems, if we multiply that with 0.155, the slope, plus the residual error, plus the intercept, it would the answer would always be the predicted value on the PHQ-9 scores. So this is how you use a dependent variable to predict an independent variable to predict a value of the independent variable, the dependent variable. So the next table, case-wise diagnostics. So what this does is it identifies cases of individuals. So row number 446 and 452 that are extreme values of that are outliers, right? So we had defined outliers using a conventional cutoff for our linear regression analysis, and we said that if there is any value that falls out of the 3 standard deviation, we would note them as outliers. So outliers are extreme values, right? And extreme values or outliers, they can affect the results of your any of your statistical tests. And I'll try to show it on a scatter plot as well. And then going on to the histograms, now we said that that for running a linear regression, right, the standardized residuals should be normally distributed, should have a near normal distribution, and we visualize that using this histogram. You see that this is it is a very beautiful normal curve. It is a bit skewed on the right side, but it's near to normal. So we can safely say that it fulfills the assumption of normality for the residuals. And then we look at the PP plot. Now the PP plot, probability plot, it is just like the histogram, but it shows you the results in the form of a scatter plot, right? So you see that the points are very much nearer to the line of total fit, and we can safely say that that these do not really significantly deviate from normality. And what we are plotting here, we are plotting the standardized residuals that we had talked about previously. And then the scatter plot between the standardized predicted value and standardized residuals, right? And what we are trying to assess here is that there is homogeneity of variance, that the data is spread out evenly as we progress through the x-axis, right? So it is spread out very in a very even manner. So we can say that that we do fulfill the assumption of homogeneity of variance of residuals, and our insights from linear regression are indeed valid, right? So I'm just going to copy paste this scatter plot and going back to the PowerPoint slide. And I'll try to demonstrate when do we violate the assumptions of linear regression. So if this scatter plot, right, this spread of data points was not evenly placed, so it's very evenly placed now, right? Evenly spread out. But if these were not evenly spread out, for instance, you may have a funnel-shaped distribution like this. The data were spread out like this, or maybe like this, right? So it would have made a funnel shape. We would have said that this is not really that the variance is heterogeneous. It's not really homogeneous, and it would have violated the assumption of linear regression, and our test would not have been valid. If there is violation of any of the assumptions, we could have moved on to nonlinear regression or polynomial regression, or weighted least square WLS regression, or maybe we would have resorted to transformation of the outcome variable into their logarithmic values. So, do we have any questions so far? Yeah, if we try to analyze it, if any of you tries to run linear regression in SPSS, would you be able to interpret it? So forget about the assumptions. Just focus on just focus on this table. Would you be comfortable enough to interpret this? So the take-home message would be that the model, the ANOVA shows regression model is significant. We move on to the next model. The variable peer problems is indeed significant. The beta value is 0.155, so it's a positive and significant association between peer problems and PHQ-9 scores. So this is the only take-home message. If you would like to know two things about interpreting any regression model. So I see we are already 20 minutes above our time, so I'll end my presentation here. We were supposed to cover a multiple linear regression and logistic regression as well, but I think that would be a bit out of scope for this workshop, and maybe we can hold more workshops on logistic regression and multiple linear regression as well, because they would require at least 2 or 3 hours of learning, because there are a lot of other assumptions to test when running those particular models as well. So do we have any questions so far regarding the use of linear regression? Yes, it does. It is a bit complex. So when I had started out learning all the statistical techniques back in third year of MBA, so that was about 6 or 7 years ago, I too had encountered a lot of problems. But I think but those problems were also because I did not really have a mentor at that time who would teach me statistics. But I'm here to help everyone, and I'm happy to explain things, and I'm happy to help you practice these in SPSS as well.
Thank you, Ahmed. I think we'll learn more when we'll start using this one.
Yeah.
I mean, just have a, excuse me. I have a question not directly related to the linear regression. As Dr. Siha mentioned, I'm planning for CAP survey outside my PhD scope. So is there, and if I have the sampling frame, is there any option to do a simple random sampling on SPSS?
So how would you be, so simple random sampling, is it by using random number generators? But do you have any
I'm not sure, but I think I'll do on SLAM. So probably I can get some socio-demographic data from from the NGOs that's working there. So while doing the the sampling, since it'll be like a survey, the cross-sectional study. So doing the sampling, can I get any support from SPSS or?
Yeah, so SPSS does have an option of random number generators, but I have this one, right? So I've not really used the random number generator on SPSS, right? But it does have an option. But you can, but I remember I had done simple random sampling using an online random number generator. So what I did was I collected the names of eligible participants for a study, right, and assigned them numbers, and then I used an online random number generator, right? So I wanted to choose about 260 participants out of 500, and I assigned all of them numbers, and using a random number generator, I generated a list of random numbers and chose those participants, who were picked in on the random number generator. That's how I did, but I don't really think you can use simple random sampling in slums if you do not really have a data on, let's say, house numbers or family numbers, or maybe name of the particular individual, right?
All right, I understand. Thank you.
Yeah. So, do you have any more questions? So once you have your own data sets, and once you have once you have once you have finalized just to the designs, we can discuss, in more detail. This was just a basic introduction to statistics using SPSS, right? Once you have your own research questions, your own study designs finalized, we can look at them, and we can choose the statistical techniques that will be most suitable for your data, and we can discuss those particular techniques with you, right? So it would be it would get more hands-on because you would have your own data and you would be able to practice, and you would also have motivation because you would know that that learning that particular technique would be really important to complete your own analysis as well. So that is a huge motivation. But I would really recommend looking at these videos again and using Oxford Handbook of Medical Statistics, as well as the other book that I had shared as reference material, and practice these and master these techniques, because these techniques make the basis of rest of the more complex statistical techniques. For instance, when we talked about the family of ANOVA test, so to understand that family of ANOVA test, you need to have a sound understanding of one-way ANOVA, right? So it's really important that you at least master this content and then move on to the techniques that are most suitable to your own data set.
And may I also add that please, and you all understand that these are complex operations or complex approaches to not only master, but also understand. I've always been helped. So this is something that I'm sharing with you, what has always helped me. I'm not a statistician by training, but I do research. And I am the person who poses all the sorts of research questions that I undertake with appropriate design. And it is the objectives and the aims and the objectives and the research questions, all the hypotheses that now I know will drive in a systematic manner. I will first describe my sample. So what Ahmed was showing us yesterday, how do you describe your sample? What are the means? What are the proportions, etc. And then you move on to your inferential. You can, yesterday Ahmed was showing, I don't know if you noticed or picked it up, that he was creating 2x2 tables to compare proportions. So girls and boys, and what's the sort of prevalence or frequency of, I think, suicidal ideation. So he created a 2x2 table, and then also imputed some chi-squaring. So he was comparing and trying to see what the correlation between two variables. So you also call that univariate analysis. Yesterday or day before, we were looking at, multiple, if you do a cross-sectional, or, if you're looking at the multiple variables which can independently explain an outcome. So what are the approaches to tease that out? So then you get into more multivariate analysis or the logistic or regression analysis. So I'm just saying that please keep in mind and keep in your focus what your aims and objectives are. Many a times, if it's just a survey, then you will just end by doing some descriptive analysis. At best, you may do some univariate or key sort of, or just a simple regression analysis where you show that certain factors are risk factors or correlates or have some form of association with, say, this burden of disease. Yeah, they're like a prevalence study, which at times also show the risk factors. So I'm just saying, don't get daunted by all of this. It will start coming in place. Once you move ahead, you do it with your own sort of hands, you read around it. And Ahmed, like said, he'll be available. So we'll all be your supervisors to help you guide. So please don't get bogged down by the complexity of all of this. Ahmed, if you want to add anything to this, or are there any other sort of comments or points from our fellows, we can then close this session. And I then need to wrap up, need to start discussing certain things with the fellows about their own individual sort of projects. So Ahmed, any points from your side?
Thank you so much, Dr. Sam. No more points from my side. I think we have pretty much discussed everything. But I would like to reiterate that, anyone can approach me either in groups or one-on-one, have one-on-one sessions with statistics with me.
Yeah, thank you very much for that. Dear fellows, any points from your side? Good. So perhaps then we can close the session. Thanks, Emma, for your
Thank you so much.
as always great support. Thank you.
Yeah. Bye. Thank you.
Bye. Right. So, do you all want to take a 10-minute comfort break, and then we can jump into the last bit of our discussions? Good. So
Yes, that'll be great. Yeah.
Yeah. So see you in 10 minutes then. Bye.
Thank you.
coffee break. Thanks, Prashani. Right, so we are all back. Great. Let me, is this the, is this visible to all of you?
Yes.
Right. So we are now at our last leg. And we've, in the last 3 days, we've covered a lot of things, design-related things, instrument-related things, analysis and stats-related things. So I thought that we'll start thinking about how to sort of apply not only the measurements but the design and etc. So as an output of this workshop, and also keeping in mind that you have next week you will be exposed to the qualitative research methods that are used in evaluative research. So once you're done with both these set of workshops, it will be good to start actually applying all of this thinking on your individual research projects. Not only the individual PhD projects, but I will encourage you to start applying all of these principles to the things that you are doing outside the scope of your PhD. So that will be that will help you start developing and internalizing all the knowledge that you are being now exposed to. So as part of this workshop's output, and we will do the same once next week we're done with the qualitative part. So it'll be good to start drawing up, what is the most appropriate research design for your and methods. And when I say research design and when I say methods, it includes all the things that will ensure that there is good internal validity. Yeah. So how do you select? Who's your participants? What's the study design? What's the question that will be helped by your research design? And since many of you are doing mixed methods, it'll be good to listen in to the next week's workshop and then start aligning both these quant and qual approaches and methods to your particular projects. And I will encourage all of you to individually or team up, however sites feel appropriate, to draw up at least a 3-pager, very simple headings, bullet points, just as placeholders, which you can expand eventually. And you'll be surprised how this 3-pager will probably be used. It's like a concept note, or even less than a concept note. Just the outlining the salient features of your study design. Yeah. Try and add to the participants. How will you select, identify what's your design, what's your instrument? So just listing them. No details whatsoever. If you have a new tool which needs to be translated, adapted, just in the brackets that prior to the actual use, you'll adapt and using A or B methodology. So it will just give you an idea of what the crux of your whole project or your research idea looks like. We've kept these are tentative deadlines. So you will have the entire 2 weeks of November, then entire 4 weeks of December, and then 4 weeks of January. So good 10 weeks, 2.5 months to keep thinking about it, keep reading around it, raise questions, use your monthly supervision meetings to pick our brains, sound it off. The more you discuss it, the more clarity you will get. So if this 31st January for your submission of these 3-pager or 2-pager or a very, a skeleton, outline skeleton of your projects is fine or feasible, we can look at it. And in a month's time, both myself and Anna, Najia, all of us, the people who've, sort of help you go through it, go through the 2 workshops, qualitative and quantitative, will review in a month's time, can feedback any points or any things that you need to think about. So by end of February, you will get your that write-up sent back to you. And I thought that for your help and for your ease to help you get into that mindset of the research methodology, I thought that I'd list down certain things, for you to start thinking, some structure. This by no means is binding, right? But these are the kinds of headings or things that encompass the outline. So pick up a study design heading, think, write. If there are 2 sort of qualitative, quantitative, then pick them up separately. Sampling techniques, we've elaborately talked about what biases can come in, sampling technique, will it be random, non-random, etc. Measurement tools, sample size, put up your rationale for both your quant as well as for qualitative. And I will encourage you to think beyond your PhD topics as well, because you're teaming up with other fellows in the site. So think about that. Then the main analytical sort of approach that you will take. Put up flow diagrams, think visually, and then start thinking and listing down what potential biases you may have. Yeah. So this will force you to keep thinking overall. So I thought I'd share this with you as a template. Again, by no means it's binding. So I'll take a pause here, hear from you if you feel this is something that will be useful, and what about the timelines, and is this something feasible? So happy to hear your thoughts. Yes, Prasansa.
So this is not like a proper protocol, but then just a 3-pager, right?
Absolutely, and this is just the blueprint of the eventual protocol, which will be much more detailed. So it's just a way to help you, or rather force you to start thinking in certain headings for your particular research project.
So yeah, regarding the timeline, the only worry we have here with the Nepal team is, yes, it's not like, so we are kind of rushing with the implementation and stuff. So if we are able to come up with sort of a blueprint anytime sooner than the given deadline, Would that be okay?
Oh, absolutely. This is just to keep this as flexible and as spread out, and it's amongst us, Prasansa and dear fellows. This is just amongst us. I know your systematic reviews are in the pipeline as well.
Mm.
You're doing certain things, preparations on the side outside the scope of your PhD. So your hands are full, your tables are full. You then have to also prepare for all the monthly sort of supervision meetings. So all of those things happening in the sites. This is something flexible, and we've just tried to keep it as simple and as bare minimum to help you have a couple of pages thought through the kinds of things that you will put in your research proposals and protocols. And why end of February? So that by May, that's the phase when majority of you will be ending your first year of your PhD enrollment. And that's the time when you will have to be submitting, except for Krishani, you'll have to be submitting your protocols for your data collection and all that. Yeah, with the year one ends with a protocol. So we thought that this is good, neatly timed. This might help you to get onto that thinking pattern of developing a protocol. But you're absolutely right. This is all flexible. If you can send them earlier, that's even better.
Sure, thank you. The only worry with our team is with the patient recruitment. So that's why we are planning to start off a little early. We fear that we might not have enough sample if we keep on delaying. So that's the only thing that we are currently worried about.
But keep in mind, Prasansa, that the protocol, I know we discussed this in your last supervision meeting as well, which was a smaller group supervision meeting, that you will have to have for your PhD, you will have to have ethical clearance from University of Liverpool. Anna will be talking about that next week. So I completely understand, as much as you're pushing this, there are two main things. One is your PhD timelines, as well as your site-related, actual on-the-ground reality. So don't get bogged down. This is just an exercise which was designed to help you materialize and think through your protocol, the meat of the protocol, which is all around this. So this will help you address all your internal validity issues. So that's the reason. Any other comments or any other concerns? Yes, Prasansa, you unmuted.
No, I just wanted to thank you.
You're welcome. So any other comments? Is this feasible? Is this something that you will be able to do or start thinking to doing? That'll be great. Good. Right. So one of the things that I would like you to do for this workshop, and you can send your feedback like last time in your email in the same thread where we had our agenda and the link and all that. Iram and Arsalan were communicating. So I would request you to, if not by the end of the day, first thing tomorrow, if you can send a couple of lines, just a set of bullet points of what you found within this workshop, which was useful and was good. And what are the things that you would like to suggest as potential improvements? So please do send that. You have the agenda with you. At times, keeping the agenda in front of you to go through the things that were covered helps you to, sort of recall that this area should have, we should have had more time spent on this area. We should have had more time spent on this area, or some other practical things should have been given to us on this area. So please, can I have a kind of agreement of this action point from all of you by end of tomorrow? If you can send these two sort of feedbacks, what was good and useful, what could have been improved. Thank you, Nabi. Thank you, Prasansa. Right, good. So I will wait for your feedback so that we have some points for the subsequent workshop. So before I end today, soon Iram or Arsalan will send you some pre-read materials for the next week. Anna suggested some things for, because she's covering ethics, and she's also covering some positional aspects of qualitative research. So very, very minor things to read through or just to glance through. She sent some materials for you to look at around the ethics application at the University of Liverpool. So very practical things. So today or tomorrow, you will have I think, if Arslan is on the call, Arslan, are you on the call?
No, Dr. Sam, he is not on the call.
So Nida, what
Yes.
I will do is I'll share the materials that Anna sent. She's requested that she should be copied in before when we send the materials out.
Right.
So that if the fellows have any follow-up questions, so she can take them up during her sessions. So just a preparatory kind of thing for Anna to do. So I'll send that to Ira. I'll copy you in as well. Right. Another request from all of you fellows is that next week, day 1, we should all switch on our videos, our cameras, and have a snapshot. I didn't press upon this because I know it's late evening in all of your sites. Bangladesh is the furthest ahead in the time zone, then Pakistan, and then Sri Lanka, and then Nepal too. So I know you must be in your jumpers, in your tracksuits, in your even in night suits. So I know it's it's odd to it feels a little awkward, but we should try and capture our ongoing this online. So I'd request that, ladies and gentlemen. So please dress up for the photo shoot first day next week, which will be the 15th. So come prepared. This is another action point. Let's put it this way. I hope you all agree. Thanks, Nabi. Right. So thanks, Nida. Yes, it's Prasansa. It's in the week of the 15th. It's a 4-day workshop, shorter days, because there are basically 4 people interacting. So we had to pick some days. So first day, and I'll if you want, I can quickly share with you all the agenda informally, but you will have a formal link as well as the agenda and all the materials sent in a separate email in a day or two. but it's the 15th, 16th, 17th, and the 18th. So these are, yes, absolutely right, Nida. And these are, if I can quickly show you. Let me, so that you just have a preemptive idea about the sorts of agenda that we will, so qualitative, yeah. So all of the days generally end at 12 p.m. GMT, yeah. So it's 4 days, yeah. Day one starts 10 minutes to 9 GMT time. The rest of the days start at the same time as we start. We've done this the entire workshop. So there will be Anna as a facilitator. Shumun is going to talk about some things. Then it will be Najia and Anam to walk you through with some hands-on practical things. So we will be sending you some pre-read. I can share this, so you get the idea. So shorter days, 4 days, yeah. Hope that helps get you mentally prepared. Are the PPT slides? Yes, I will put up my set of slides on PebblePad along with all the resource material that I was referring to. Those are generally articles and MRC framework, the new one as well, and an article around it as well. So, yeah. Professor Dollar Wang has also sent some materials. So this will all be on the PebblePad. And last but not the least, since you're all here, Atif gets, because he's primary supervisor for all of you, majority of you. So he received an email from PGR that I think one of you, I don't remember if it's Nabi or, so somebody was falling behind the designated number of supervisory meetings. So please, all of you, make a mental note that all of these monthly meetings that we do should be used as tick-off of monthly supervision meetings and have them in your toolbox, PGR toolbox, yeah, so that myself and Atif can sign them off. So please make a mental note. I hope this is registered. Raise your hands, please, so that I am reassured that this point that I'm making is picked up. So Nabi, I need your acknowledgement, Rashani.
Yeah, I mean, I think it's me. I was having problem getting access to PebblePad.
Okay.
Sorry, to Liverpool Live. So
no worries.
That's why probably,
no
I
worries.
send an email to the system. I'll fix it as soon as I get.
And I'm just, yeah, all that I'm saying is that even if it is the turn of the PhD fellow with the detailed update, or it's just a 10-minute update, please have these monthly first Monday meetings of ours each month represented as your monthly supervision meetings, right? So with this, let's bring this workshop, quant-related workshop to an end. As always, lovely talking to you. And inshallah, next week, we will join up again for the qualitative part. And please keep tuned in. You will have further information regarding the next week. So if there aren't any comments, suggestions, let's sign off. Have a great rest of the evening. We'll look forward to catching up with you over emails.
Thank you. Bye-bye.
Bye, everyone.
Thank you so much.
Thank
Bye-bye.
you, Dr.
You're most
Sam.
welcome.
Thank you.
Khuda Hafiz, namaste, good evening, and stay well.
Thank you. Bye.